Hello viewers. Today we will discuss concept of a force and I will try to discuss it in context of Newtonian mechanics. So before we start discussing concept of a force, there are certain prerequisite concepts that we need to know, and I will assume that these concepts have been unambiguously understood before we move ahead with the definition of force. These concepts are mass, space, time, velocity, and acceleration. With background of understanding of these concepts, now let us try and ask a question. What is a force? So most of the texts define force as an external agency that tends to change the state of rest or of uniform motion of a body along a straight line. In its slightly modified form, this precisely is the statement of Newton's first law. Every body continues to remain in its state of rest or of uniform motion along a straight line unless it is acted upon by an external agency termed as force. This statement has two parts, so let us understand them one by one. So if there is an isolated body in space which is at rest, any external agency that tends to change the state of rest of that body, we are going to term it as a force. We have to understand here that the success of that external agency in putting the body on motion is immaterial. Whether it succeeds in doing so or not, as long as it attempts, we are going to call it as a force. The second part of this statement is, if there is an isolated body in a space which keeps on moving with a uniform velocity along a straight line, and any external agency that tends to change either magnitude of direction of this velocity will be termed as force, irrespective of whether it is successful in doing so or not. If we carefully look at this statement of Newton's first law, these are effects of forces. So we have a philosophical objection here. How can we define a physical quantity just merely looking at few of its effects? Therefore, Newton's first law clearly is not the definition of a force. Now let us try our luck with Newton's second law. So Newton's second law states an unbalanced force in a particular direction acting on a body must be equal to the change of momentum of that body with reference to time in that particular direction. This statement in its equation form can be written this way. Unfortunately, most of the texts write left hand side as F. We have to understand that it is not a force, it is unbalanced force in a particular direction. Therefore, we must denote it by summation F or sigma F. And on the right hand side, most of the texts do write it as mass into acceleration. We have to again understand that there are situations where mass is function of time. For example, let us say a rocket is sending a satellite in its orbital. Thousands of gallons of fuel is getting burnt every second, and therefore mass is not constant in this case. So there are situations where we will deal with the situation, we will deal with a phenomena where mass does not remain constant over the period of observation, and therefore we have to write down the statement of Newton's second law in the way I have written it down. If mass remains constant with reference to time during the motion or during the period of observation, then we can take mass outside derivative sign, and then we can write it as mass into acceleration in that particular direction. But again, Newton's second law specifies the relationship between mass, acceleration, and unbalanced force. It does not specify the definition of a force. So Newton's first law and Newton's second law do not define what a force is. So what is the classical definition of a force? So force by definition is action of one body on the other. Let us look at this definition more carefully. What does it try to say? It obviously says for existence of a force, you cannot have you cannot have an isolated body. At least two bodies are required for existence of a force, and therefore force would not exist if there are no two bodies. Shall these bodies be in contact? Answer is no, not necessarily. This definition does not say whether the two bodies that are involved must be in contact or not. For example, consider a gravitational force. Even if the object and, let us say, Earth is not in contact, the gravitational force does prevail and two bodies are the object and the Earth. Therefore, let us summarize. Force is action of one body on the other. This definition makes it mandatory that for existence of a force, we must have two bodies. And second, these two bodies did not necessarily be in contact. So I think we have now unambiguously defined what a force is. Now in the next short video, we will be discussing what is the complete definition of force. For example, if I ask you what is the temperature at this point in space, we say it is 10 degrees Celsius. So therefore 10 is magnitude. Degree Celsius is the specified system of units. So magnitude and specified system of units is sufficient to describe temperature at a point in space. In the similar context, we will try and understand in next short video what is the complete description of a force. So with this, let us stop here as far as this video is concerned. Thank you.